Hello, this is Dr. Christy Lukes, and this is the solution to Exam 2 for our Thermo 1 course. So now let's look at this last problem and consider a process where you have a substance and different people had different substances, but in this one, in butane. Data is here in this top line. It's heated from 297.57 to 382.59 Kelvin. And so if we convert those to reduced values, 297.57 over TC, 425.1 is 0.7, and TR at 382.59 over 425.1 is 0.9. Now it says that this is going to be a gas if the pressure is 3.796 bar, and it's a liquid when the pressure is 75.92 bar. So the pressure for the gas, if I reduce that, 3.796 divided by 37.96, this number right here, is 0.1. And the pressure for the liquid, if I reduce that, it's 75.92 over 37.96, and that is 2. Now, what we're asked to do is use the information shown below. So we have a Liderson chart, which is used for liquids. And down here we have our values for the generalized information that we're going to use for our gas. And so if we do the calculations for the liquids first, we want to use V at T2 and V at T1, the difference between those. And to get that, we need, for liquids, the pressure is 2 reduced, so on this line here, and our temperature 1, we're on 0.7, so we're at this point, which looks to be about rho R1 is about 2.6, and rho R2, temperature is 0.9, so it's on this curve, and it looks like about 2.1. Now if we use these definitions, you can do it various ways, but probably the easiest is to use this. So V is going to be V sub C over this reduced value of density. And V sub C is, in this case, 255. And so V1 is 98 cubic centimeters per mole. And V2 is 121.43 cubic centimeters per mole. And therefore, my delta V for the liquid, 23.35 cubic centimeters per mole. Now for my gas, I'm going to use the generalized charts down here, and my gas pressure is 0.1, and T is going from, in this case, 0.7 to 0.9, and so I have my Z0 values here, and from this table, my Z1 values here, and omega is equal to 0.2. So therefore, Z for state 1 is 0.8958 plus 0.2 times negative 0.1161, or 0.87258. At state 2 it's 0.9528 plus 0.2, that's my omega, times negative 0.0205, and this is 0.9487, all gas-like values. And delta V for the gas, well, I can use PV equals ZRT. And so this is going to be, in this case, R and P are constant. So R over P times Z2 T2 minus Z1 T1. And if I use 83.14, the units on that are bar, centimeters cubed per mole Kelvin. Divide by my my pressure rather, which is 3.796 bar. Z2 is 0.9487 times T2. Now I want T, not the reduced T. 382.59 minus Z1, 0.87258 times T1, which is 297.57, and delta V for my gas looks like it's 2263 cubic centimeters per mole. I asked you to compare these as a ratio, and it's about 23.35 over 2263. Now your numbers for that numerator will vary a little bit because we're reading from a graph, but you should get something on the order of 0.01, and there are no units associated with that. So this concludes our test. Thank you very much.